Good morning. In my presentation, I'm going to just give you an overview of the emission sources in California. And we're going to talk about some of the ongoing effort that California Air Resource Board is working in collaboration with different agencies on doing additional study and research to help us improve our inventory as well as improve our understanding of emissions. And lastly, we're going to talk a little bit about how bottom out emission inventory method compare with ambient monitoring. The California Greenhouse Gas Emission Inventory is a living repository of detailed methodology for estimating greenhouse gas emissions, providing a platform to compare the relative contribution of different sources to climate change over time. The inventory includes 6 pollutants identified in the Kyoto Protocol. They are carbon dioxide, methane, nitrous oxide, hydrofluorocarbon, fluorocarbon, and sulfur hexafluoride, plus the 6th pollutant, nitrogen trifluoride, which was later added to the inventory. The transportation sector is the largest source of greenhouse gas emissions in California, accounting for 37% of emissions. Contributions from the transportation sector include emissions from combustion of fuel used by on-road and off-road vehicles, aviation, railroad, and waterborne vehicles. Emissions from electric power sector comprise 20% of the statewide emissions. The electric power sector is divided into in-state power generation and imported electricity. Emissions from the industrial sector contribute 20% of the total emissions. Emissions in this sector are driven by fuel combustion from sources that include refineries, oil and gas extraction, cement plants, and other stationary sources. And emissions from the commercial residential sectors are driven by the combustion of natural gas and other fuels for household use and for providing energy for commercial business. The agriculture sector contributes approximately 8% of the statewide emissions, mainly from methane and nitrous oxide sources. The emissions in the sector include interior fermentation, manure management from livestock, fertilizer use, soil preparation and disturbances, crop residue burning, as well as fuel combustion associated with agriculture activities. ARB staff routinely evaluates the methodologies used to develop emission estimates in the inventory. Data from a variety of sources are reviewed and compiled for use in updating the inventory each year. Updates to methodology are an ongoing process. ARB makes improvements to the methods, data, and emission factors used to determine greenhouse gas emissions. Recalculations are made to incorporate new methods or to reflect change in statistical data supplied by other agencies. The Greenhouse Gas Inventory team also provides routine and special analysis to support various projects and research studies. ARB is currently in the process of developing regionalization of the statewide greenhouse gas inventory to provide comparable spatial scale to regional ambient measurement studies. In the remainder of this presentation, I will walk through some of the ongoing efforts that ARB is taking to apply science to better understand the characteristics of emission sources. In 2011, ARB contracted with researchers from UC Berkeley to develop a new methodology for assessing carbon stock change on land. The researchers developed a new emissions assessment approach based on field measurements and satellite remote sensing data and methods. The methodology includes an emissions assessment of forests, woodlands, grasslands, shrublands, and wetlands. Recently developed tools will enable ARB to generate geospatially explicit estimates of ecosystem carbon stocks and greenhouse gas flux associated with stock change across a variety of land categories. Additional work is needed to evaluate the data provided by the Berkeley research and to incorporate additional new data and to identify further research needs to expand use of these tools. Continued refinements will advance carbon quantification, attribution of greenhouse gas flux by disturbance process, and reduce uncertainty. As source data improves and methods are refined, ARB greenhouse gas inventory for forests and other lands will be updated. And we're going to hear more about that later from the second speaker. The methodology developed by UC Berkeley does not include tree cover urban areas. CAL FIRE, in conjunction with the U.S. Forest Service and researchers at UC Davis, recently developed greenhouse gas inventory data for urban forests. Together with the forest and other land inventory, this work on urban forests helps provide a comprehensive picture of California carbon stock on land. Greenhouse gas has different atmospheric lifetimes, ranging from less than a year to thousands of years. Some greenhouse gas have shorter lifetime because they are removed quickly from the atmosphere. Short-lived climate pollutants include black carbon, methane, and some hydrofluorocarbons. Methane and black carbon account for more than 35% of climate forcing on a short-term, 20-year global warming potential basis. Our recent effort to study emission sources has focused on methane. Anthropogenic methane sources include interior fermentation, manure management, landfills, natural gas transmission, and wastewater treatment. There are also non-anthropogenic sources such as wetlands, ocean, forests, fires, and termites. Agriculture represents the largest methane source, accounting for approximately 2/3 of the total emissions. Approximately half of the methane generated from livestock comes from methane storage lagoons, and the other half coming from interior fermentation. Methane is also emitted from oil production and the natural gas industry. Natural gas is transported under high pressure, long distance from field production areas to distribution systems. Methane is emitted from venting and leaks of process equipment and pipelines. Methane is also generated in landfill during the natural process of bacterial decomposition of organic materials. The type and age of waste vary in the landfill. The quantity and types of organic compounds in the landfill and the moisture content of waste can influence the quantity and composition of the generated landfill gas. It's going backwards here. ARB is currently funding studies to help better understand emissions in the oil and gas sector. There is a study currently in progress that will develop California-specific emission factors for natural gas transmission and distribution. It includes main and service distribution pipelines, as well as above and below ground leak measurements. In a recent ARB-sponsored study, emission measurements from well stimulation operations were collected from a limited number of samples. As a part of this study, limited measurements were also taken at an oil production wastewater evacuation pond. ARB will be looking to collect additional greenhouse gas, VOC, and toxic air contaminant emission data on oil production wastewater ponds. There is also a study being planned right now to measure methane emissions and characterization of abandoned and inactive wells. It will help us quantify fugitive emissions from these sources. The foundation of ARB's measurement program is the Statewide Greenhouse Gas Monitoring Network. The network was initiated in 2010 with a permanent station at Mount Wilson Observatory in the Los Angeles basin. Since then, ARB has expanded the network to 7 ARB-operated stations, and 4 additional stations are operated by leading researchers throughout the state. In addition, ARB also collaborated with research partners on several other monitoring locations. We have equipped these stations with state-of-the-art monitors for carbon dioxide, methane, N2O, and black carbon. We are also deploying analyzers capable of measuring methane isotopes to get a better understanding of emission sources. Together, this network is a first of its kind greenhouse gas monitoring effort. ARB is further improving the methane emission inventory with ongoing coordinated research with other agencies. ARB and the California Energy Commission have several ongoing partnerships for measurement and evaluation of methane emission sources in the energy sector. ARB's statewide methane monitoring network provides a record of real-time methane concentrations, and the efforts are greatly supported by CEC and our sister agencies. Data from this network were used in several research contracts and form the basis of a comprehensive statewide inverse receptor-oriented modeling and various trend assessment analysis to verify and inform the greenhouse gas inventory. ARB is also actively participating in the Megacities Carbon Project in the South Coast Air Basin, which is developing and testing methods for monitoring various greenhouse gas emissions to link measure concentrations to emission activity. In addition, researchers at ARB, CEC, and NASA's Jet Propulsion Laboratory are collaborating to identify large hotspot methane sources through a systematic survey using aerial and ground measurements to provide a greater understanding of methane sources. Collectively, all these efforts are expected to vastly improve our understanding of methane sources. And you're going to hear more about that later with another speaker in the session. Three methane studies using aircraft measurements and greenhouse gas monitoring network data suggest that statewide methane emissions are greater than previously known. As shown on the map, the majority of emissions are located in the Central Valley, and ongoing research in collaboration with our partners is expected to provide new information to better understand sources of methane and their emissions. The very first pilot study at Mount Wilson started in 2007 and focused on methane emissions. The 2007 ambient measurements indicated higher methane emissions than estimation using bottom-up inventory methods for the Los Angeles County. As ARB routinely makes improvements to these methods, data and emissions factors used to determine emissions over the years, it makes recalculation to incorporate new methods or to reflect changes in statistical data from other agencies. The bottom-up methane estimation now correlates well with ambient monitoring data for year 2007. ARB is collaborating with others on a variety of measurements, including satellite measurements, aerial measurements, and ground-level measurements like tower, mobile measurements, and field study, and remote sensing study, and also laboratory studies. ARB is using science to inform greenhouse gas emission estimation, investing efforts to help us gain a better understanding of emission sources, and partnering with other agency researchers to learn more about the characteristics of emissions. These works will help us verify and improve inventory estimation over time. Research collaboration will continue to provide new information to help California better understand the emissions. And this concludes my presentation.